Today we're going to work through the Unit 10 review, and on your next class you will have your Chapter 10 test. Hopefully you've made good progress working through the Unit 10 review on your own already. If you have not, please do that before you watch or listen to this PowerPoint, this video. You can always pause it if you need to, finish writing what you need to write, or rewind it so that you can see something again. Please do not watch this on a faster speed than normal speed. You'll miss some explanations, and the whole point of going through this is to make sure that you understand how to work each one of these questions. All right, so looking at the Chapter 10 test review, it says that assume that the lines that appear to be tangent are tangent. Recall that if they are tangent, then they are perpendicular. Perpendicular, that's the symbol for perpendicular to the radii, to each one to the radius at the point of tangency, which tells us that this is a right angle right here, and this is a right angle right here. That's what that tells us. And it wants us to find the value of x. It tells us that the measure of angle O is 135 degrees, so this angle is 135 degrees. Recall that the sum of the interior angles of a quadrilateral is always 360 degrees. You may also recall that opposite angles are supplementary. Opposite angles are supplementary. Okay, please make sure that you are taking complete notes as we work our way through this review. We will take this up for a grade. All right, so if we know that opposite angles are supplementary, then that tells us that 135 degrees and x are supplementary, meaning they add up to 180 degrees. So if x plus 135 equals 180 degrees, then we simply need to subtract 135 from 180 and we will get our answer here. Now you could also use the fact that the sum of the interior angles is 360 and add 135, 90, and 90, and then subtract that from 360. You'll get the same result. All right, so once we subtract here, we'll get that x is 45 degrees. Now these questions, these 25 questions that are on the review are the exact same questions that are on the test, but the numbers are different in them, and they'll be in a different order. So this very question will be on the test, but angle O will not be 135 degrees. It'll be a different measure. So make sure that you understand how to work these. If you have any questions or do not understand how to work them, please ask your geometry teacher, or you can send your geometry teacher an email if you are at home, or send them a message on Remind. All right. Looking at number 2 here. Again, it says that lines appear to be tangent are tangent. So we have a tangent here, PQ. So we know that Q is a right angle. And it says that angle P is 14 degrees. So we have 14 degrees here. So again, we're going to use the triangle sum theorem, which tells us that all of the angles of any triangle add up to 180. You can add them all up and say 90 plus 14 plus x equals 180. Or you may notice that in any right triangle, the acute angles must add up to 90, and you can simply say 14 plus x equals 90, and just subtract 14 from 90. You'll get the same result. Right, so if you do it this way, 90 plus 14 is 104, plus x equals 180. So then you would simply need to subtract 104 from 180. Notice that whichever way you do this, you will get 76 degrees. You get 76 up here also. Okay. Please make sure again that you're taking complete notes. If I end up moving too quickly, please feel free to pause it and make sure that you can get all of this on your review. If you just write answers, it's not helping you. You need to make sure that you get the processes on here as well. This one shows you that AB is tangent. That tells you that angle O is a right angle, because the tangent is always perpendicular to the radius. This says if AO is 24, anytime it gives you information, put it in the figure. If AO is 24, then label AO 24. And BC is 50, then what is AB? So we're looking for AB. Well, notice that AO and CO are both radii. So CO is also 24. So the length of BO, which will be the hypotenuse of this right triangle then, is 74. And we simply need to do the Pythagorean theorem, unless you know that this is a Pythagorean triple. We may find out that it's a triple. Once we finish working it, we'll see. So the legs are x and 24. X squared plus 24 squared equals 74 squared. And we're just doing the math here. We have 24 squared, which gives us 576. And we have 74 squared, which gives us 5476, 5,476. And I can tell already this is going to be a triple. So we're going to subtract 576 from both sides, which is going to give us 4,900. I can tell already, because I know that the square root of 49 is 7, and I have 2 zeros there. So x is the square root of 4,900. In your calculator, you can do the square root of 4,900. There we go. I see that this is, in fact, 70. So we have a 70, 24, 74 triple there. Neat. Okay. And again, on the test, AO won't be 24, BC won't be 50, but the question will be the same. So just make sure that you followed and understand how that is to be worked. On 4, it says that AB is tangent at B. So again, we have a right angle here. It says to find the length of the radius for AB equals 9. So label AB 9. And for AO, which is the entire hypotenuse, being 10.5. So this is simply a Pythagorean theorem problem. So I have 9 squared plus r squared equals 10.5 squared, and I'm doing the math here. I already know that 9 squared is 81. I hope you do too. On my calculator, I'm doing 10.5 squared. 10.5 squared is 110.25. Okay. Just need to subtract the 81 from that and take the square root. That tells me that r squared is 29.25. So my radius is the square root of 29.25, which is, so the radius equals approximately, and this wants us to round to the nearest tenth. So I have 5.408. If I'm rounding to the nearest tenth, then I'm looking at the number after it to see whether I should round it up or down, or whether I should round it up or leave it the same. And I do end up with approximately 5.4 here. Okay. Number 5. This tells us that JK, KL, and LJ are all tangent to the circle, and they want the perimeter of triangle JKL. And they give us some lengths here. It also tells us that JK is congruent to JL. So we have JA is 9. We have that AL is 10. And we have that CK is 14. I see the problem. AL is 10. So if AL is 10 and these are tangent as shown, then LC is also 10. If CK is 14, then BK is also 14. And if JA is 9, then JB is also 9. So with this given information, or with these given measures, the length of LJ is 19, and the length of JK is not 19, it's 23, so they can't be congruent. But if we're just looking for the perimeter here, then we just need to add up the lengths of all those sides. And we did this a little bit differently in class, and I'll show that again in just a second. And I will verify this answer and correct it if I need to. So we're adding all these together here. 4 and 3 is 7, plus 9 is 16. Carry my 1, 2, 4, 5, 6. I get 66 for my perimeter. Now, the other way that we looked at this in class, we have 9 and 9, which is 18. Just use your doubles. Double 9 is 18, double 10 is 20, and double 14 is 28. So we could use those numbers to add together. 20, 28, and 18. Again, you can see here that you're going to end up with 66. So whichever way is better for you, please do that. Okay, this says in circle A, NA is congruent to PA. So this is an important concept. If you have chords that are equidistant from the center, as we do here, then you know that those chords are congruent to each other, and their arcs are as well. So this tells us that MO is perpendicular to AN, which means that AN is a perpendicular bisector of that chord. And the same thing is true over here, where RO is perpendicular to PA. So PA is a perpendicular bisector of that chord. I'm doing 2 slashes there also because we already know they're congruent. This tells us that MO is 5 feet from M to O, which means that RO is also 5 feet. Well, they're asking us for PO. PO is half of that, so that would be 2.5. 2.5 feet is what we're looking for there. Right on 7 here, it says find the value of x. If necessary, round your answer to the nearest tenth. In these problems, where the number is where they intend it to be, meaning that 12 is only half of this chord, which means 12 is also over here. So with problems like this, you want to draw on another radius so that you've created a right triangle. Now, since all radii are congruent, that other radius is also x. So I have 9 and 12 as my legs here. So hopefully you can see that both of these are divisible by 3. And 9 is 3 times 3. 12 is 4 times 3. So I have a triple. 3, 4, and so this must be 5. Also times 3, which is going to give you 15. Now you absolutely could have just done the Pythagorean theorem there and said 9 squared plus 12 squared equals x squared. And you said 81 plus 144, which is 225, equals x squared. So x is the square root of 225, which just so happens to be 15. Okay, on 8 here. So on 7, I had mentioned that the numbers are where they are supposed to be, which meaning that 12 was only half of that. Here, 20 is in the middle, which means that each part of this chord that is bisected is 10. You have 10 here and 10 here. 20 being in the middle tells you that the entire thing is 20. All right, so I'm going to draw again my radius here from O to the end of that chord to show that this is a right triangle. And I'm going to do Pythagorean theorem here. I have 5 squared plus 10 squared equals x squared, or 25 plus 100, or 125 equals x squared. So x is the square root of 125, which is going to be 11 point something, I do believe. And I'm not sure if this is going to give you the answer in square root form or not, so just make sure that you understand both, or how to find the square root if it's not in square root form. So in your calculator, the square root of 125 gives you approximately 11.18. And did it ask for this? It did. Round your answer to the nearest tenth. Okay, so this is that 8 is big enough to round the 1 up. So my answer will be approximately 11.2. And number 9. Number 9, it says AB is a diameter, and that's an important thing to note. If it's a diameter, that means it cuts this triangle in half. And the inscribed angle is a right angle. So I know that that's a right angle, and I know that that's a right angle. And it does tell me here that AB is perpendicular to CD. So that's a right angle. And they're all the way around too. okay? And if the diameter is perpendicular to a chord, it also bisects it. So this piece is equal to this piece. We may not even need this information, but a review is always good. Okay, this tells us to find the measure of arc BD. Arc BD, so this is what we're looking for. And it tells us that the measure of arc AC is 59 degrees there. Okay? All right, so if we're looking for where this takes us, okay? So we have all kinds of different triangles here, but let me use a highlighter to help make this make sense here. This inscribed angle here intercepts that 59-degree arc, which means that it's going to be half of it. If that's half of the arc, half of 59, or 59 divided by 2, is going to give us this angle right here, okay? So 59 divided by 2, well, 60 divided by 2 is 30, so 58 divided by 2 would be 29. So 59 divided by 2 is going to be 29.5. So this is 29.5 degrees right here. Now, we're looking for arc BD, which is the arc that is intercepted by inscribed angle DAB. So we can find that angle now because we have this right triangle here, and we know that this is a right angle, and we know that this other acute angle is 29.5. So to find this angle, which is the angle that we want, that will be half of the arc, we can use triangle sum theorem, or we can know that the acute angles in a right triangle are always complementary. So we have 90 minus 29.5. Well, if I did 90 minus 30, that would give me 60, but I took 0.5 too much. So I should have 60.5 here for my angle, 60.5. Recall that an arc is always double the measure of the inscribed angle. So 2 times 60.5 will give us the measure of arc BD. 2 times 60.5 should be 121 degrees. 121 degrees. Now that was a little much, so make sure that you understand what I did. Feel free to pause it or rewind it if that helps you. And this is on Canvas, so you can always watch it right before the test even. All right, so looking at number 10 here. We have WZ and XR that are diameters, and that helps us because we know that they cut the circles in half. So we know that this is 180 degrees, and so is the other half. And we know that also for this, 180 degrees. All right, this wants the measure of arc ZWX. So I'm going to highlight over what I'm ultimately looking for. I'm going from Z to X, but I have to go through W to get there. Okay, so ZWX then is going to be this entire piece here. All right, well, I know that this much of it, let me go highlighter still. This much of it is 180, right? And I know that this other piece right here is 31. So I just need 180 plus 31. 180 plus 31. 180 plus 20 is 200. You have another 11 there. So you should have 211 degrees. All right. On number 11 here, this wants me to find X. So recall here that the inscribed angle is always half the measure of the arc that it intercepts. So this is simply 41 divided by 2. Well, 4 divided by 2 would be 20 and a half, so you have 0.5. 20.5 degrees. Okay. On number 12 here, this wants to find the measure of angle BAC, which is this angle right here that I'm putting that X in. So, a couple of different ways to do this. You could find this arc measure and take half of it. You could find this other angle here because they add up to 180. You could find this arc measure because this arc measure is going to be the same as the central angle. Now you can find the other one. Or you could recognize that since AO and BO are both radii, that this is an isosceles triangle. So this is also X, and you could just subtract 85 from 180 and then divide by 2. Effectively, it all does the same thing. All right. Since this is a straight line, AC, so it adds up to 180. So the angle that we're looking for, which is the same as the arc that it intercepts, is simply 180 minus 85, which is 95. Okay, so this angle is 95. And this arc is 95 because the central angle is always the same as the arc that it intercepts. So the angle we're looking for is just half of 95. So 95 divided by 2. Okay? All right. 90 divided by 2. 90 divided by 2 is 45, right? Divided by 2, sorry. It is 45. 94 divided by 2 would give us 47. So 95 divided by 2 is going to give us 47.5. And I'm sure you all just punch that into your calculator. But please don't be afraid to work on a little number sense and mental math, particularly for those of you that want to improve your ACT score. That is the way to do that. All right, we are almost halfway done. So looking at number 13, it says given that DAB and DCB are right angles, so mark them. DAB is a right angle, DCB is a right angle. It says, and that the measure of angle BDC, this one right here, is 52 degrees. Now what is the measure of arc CAD? Well, before I even look at CAD and what I'm looking for there, I'm going to finish some information here in my figure. Since this inscribed angle is 52, I know that the arc that it intercepts is going to be double that, or 104, which tells me that this other arc here, since DB cuts the circle in half, this other arc here, DC, is going to be 104's supplement, or 76. And then angle DBC here, or the other angle in this right triangle here, is going to be half of that, or 38. You could also just work the triangle sum theorem, and seeing that 52 from 90 gives you 38 there. Okay? All right, so this is looking for arc CAD. So let's look and see what that is. I got to start at C. I got to end at D, and I have to go through A to get there. So I'm looking for this entire arc here, which, lo and behold, is the entire circle except for 76. So all I need to do here then is take my 360 and subtract 76 from that. Okay, so if I subtracted 60 from that, that would give me 300, but I need to subtract 16 more. So if I subtract 10 more, then I've got 290. I need to subtract 6 more. It's going to give me 284. 284. And I may have already punched that in long before now. But again, always working on mental math and keep your brain active. It's important. You'll learn how important someday, if you don't already know. Okay, 14. AC is tangent to circle O at A, which means that this is a right angle, but I don't think we need that information. We'll see. This is the measure of arc BY is 24. Since this is circle O, that means that this is a diameter. It's half of the circle. So if BYA is 180 degrees, then arc YA is going to be 180 minus the 24. 180 minus 20 would give us 160. Minus 4 more would give us 156. So it's a 156 degree arc. This is an inscribed angle. So the inscribed angle is going to be half of that. This is an inscribed angle. That's what we're looking for here. Angle YAC. So we want 156 divided by 2. 156 divided by 2. Well, 150 divided by 2 is 75. And 6 divided by 2 is 3. So we're looking at, show that here, is 3. So 75 and 3 is 78. All right, so that was an angle, so 78 degrees. Okay. Looking at 15. This tells us that PQ is tangent to the circle. That's good. In the circle, it says the measure of arc AD. Arc AD right here is 92. The measure of angle D is 78. Okay. So before I even really look at what I'm trying to find, I'm going to complete as much of this figure as I can. All right. So the measure of angle D is 78. That is an inscribed angle, which means that the arc that it intercepts, which is all of that. Now maybe should do this in highlighter so I can see a little bit better. That's the inscribed angle, and it intercepts this entire arc right here. The inscribed angle is always half of the arc that it intercepts. So since angle D is 78, then the arc is double that, or 78 times 2, which gives us 156. And then we know that this portion of the circle is 92. And we can find the other portion of the circle, change colors, which is this arc right here, arc DC, because we have the rest of the circle. So we're going to take 360 and we're going to subtract the rest of the circle, which is 156 plus 92. 156 plus 92, 6 and 2 is 8. 5 and 9 is 14. Carry my 1, so I have 248. 360 minus 248. I'm going to write this vertically to make it a little bit easier to do. 3 minus 2 is 1. 6 minus 2 is 4, but I'm subtracting 8 from 0, so it's going to be not 2, but 1. And 12. And you can double check this. 8 plus 2 is 0, or 10, sorry. Put down the 0, carry your 1, 4, 5, 6, and 3. So yes, 112 is the degree measure of this arc. This arc here. We're wanting an angle DCQ, and these angles do function as inscribed angles. So the angle then, if the arc is 112, the angle is going to be half of that. We want 112 divided by 2, which is going to give us 56 degrees. 56 degrees is ultimately what we're looking at here. It's a little bit all over the place. If you got lost or confused at any point during that, please pause it, rewind it, watch it again. Make sure you understand how we got that. Okay? All right, look at 16 here. This tells us that arc DE is 120. 120. Tells us that arc BC is 53. We're looking for the measure of angle A. So in class, I mentioned that we want to make sure that the angles that we are, or the arcs that we are subtracting, are the ones that are inside the mouth. So those are the two arcs that are inside the mouth. When you have the vertex outside, you are going to subtract the arcs. So 120 minus 53, and then divide by 2 to get the angle that is formed there. 120 minus 50 is 70. 70 minus 3 is 67. And then 67 divided by 2. Well, 66 divided by 2 would be 33. So then we have another half. So 33.5. There's a 33.5 degree angle. And again, you could punch all this into your calculator if you are not wanting to exercise your brain at this time. But it's always a good time to exercise your brain. Unless you're sleeping. You shouldn't exercise your brain then. Definitely not. You need to sleep. All right. Number 17. Here we have arc AB, which is 46. And we have arc CD, which is 25. So again, we do have the arcs that are hugged or intercepted by this angle that you're looking for and its vertical angle. So when the vertex is on the inside, we need to add these arcs together. 46 plus 25, and then divide by 2. Well, 46 plus 25, 40 and 20 is 60. 6 plus 5 is 11, so we have 71 divided by 2. 70 divided by 2 would be 35, so here we have 35.5 degrees. We are looking at an angle here. Don't be afraid of decimals. They are real life. 71. Okay, looking at 18 here. This says that DA is a tangent to a circle at A and DC is a tangent at C. Wants us to find the measure of angle D for angle B being 56 degrees. 56 degrees. Well, here's a fun one. All right, so we have two tangents. We have two tangents that are meeting outside the circle. So what we need to do is we need to take, let me get some highlighters here, the big inscribed angle, or the big arc and the small arc, and we need to subtract those and then divide by 2. Subtract and divide by 2 to get angle D. I'll put a variable there, angle D. We don't have either one of them, but that's okay because we do have this inscribed angle, this 56 degree inscribed angle. And we can simply double that to get the arc that it intercepts. So that tells us that arc AC here is 112, because half of it is 56. And we can find arc ABC by subtracting that 112 from 360. 112 from 360. Well, 360 minus 110 would be 250. And we take away 2 more, we have 248. Okay, so we have 248 and we have 112. We want to subtract those. 248 minus 112 and then divide that by 2 to get our angle there. All right, so subtracting these, I'm going to put these vertically just so I can see them a little bit better. I'm trying to minimize the mistakes I make when I'm recording. All right, 8 minus 2, 4 minus 1, 2 minus 1. So I have 136 divided by 2. Well, 120 divided by 2 is going to give me 60, and I have 16 more there. 16 divided by 2 is 8, so I'm looking at 68 degrees. Check me. All right. Looking at number 19. This is one of those where you have two chords meeting inside and you're looking for a segment measure. So take one of the chords, find the two pieces of the chord. That red chord has pieces of 9 and x. I'm going to multiply those together. Then I'm going to look at the other chord. This other chord here, this blue chord. I can see the pieces are 6 and 16. I'm setting that equal to 6 times 16. That's it. I'm just doing the math here. Okay, so 9x equals 6 times 6 is 36. Carry my 3. So 6 times 16 is 96. All I need to do here is divide 96 by 9. 96 divided by 9 gives me exactly 10.6 repeating, which is 10.6666666. It goes on forever. But it wants us to round our answer to the nearest tenth. So if we round it, that 6 is big enough to round the 6 up. So I get approximately 10.7. Please make sure that you are rounding correctly. Rounding can be the difference between an incorrect answer and the one you should mark. All right, looking at 20. This tells us that the length of segment AB is 20. The length of segment BC is 6. The length of segment CD is 8, and we're looking for x. This is two secants meeting outside a circle. If we're looking for a segment measure, then we are looking at outer piece times the whole thing here being x plus 8. And then again we have outer piece times the whole thing for AC being 20 plus 6 or 26. So to set this up, we've got the outer piece of 8 times the whole thing x plus 8 equals the outer piece of 6 times the whole thing of 26. Don't forget that you will need to distribute the 8 through the parentheses. So I have 8x plus 64 equals, and then I have 6 times 26. 6 times 6 is 36. Carry my 3, and then I have 12 plus 3 is 15. So then this is just a two-step algebra problem. I'm subtracting 64 from both sides, and I get that 8x equals 92, I think. That's 2. That looks right, I believe. So I'm dividing both sides by 8 here then. And we'll see what I get. 92 divided by 8. Give me 11.5. All right. Take your time. If you were confused at all, please watch it again. Make sure you understand it before the test. All right, 21 here. Ultimately, it wants the measure of arc CDE. So I'm going to start at C, go around to E, but I have to go through D to get there. So I'm using all of that. Okay? All right, so I need to find, well, I can do this a couple of different ways. I could just add the 3 arcs on the other side, or the 3 angles on the other side, because they're all central angles here, and subtract that from 360. Let me do that. That'll be fun. All right, so I have my 103, my 50, and my 35. And that is giving me 188. 188, okay? So then what I'm actually looking for is going to be the rest of the circle, or 360 minus 188. So 360 minus 188 gives us 172. Okay, 172 degrees. Another way to work this would be, since you're looking at circle O here, would be to find this angle and then add that to the 27, because this is half a circle. So this is 180 minus 35, which is 145. And then you would add the 145 to the 27, and again get your 172. Either way, you're going to get 172. And again, it won't be 172 on the test, but it will be the same question. So please make sure that you understand how to work it. On 22, we want circumference. Circumference is 2 pi times the radius, or pi times the diameter. In this case, we're given the diameter. So all we need, because it wants us to leave your answer in terms of pi, let's just take the diameter, 5.7, and put a pi after it. That's quite literally it. No thought there. Just understanding the formula. Okay, 23 wants the length of arc YPX. Okay, so we're starting with Y. We got to end at X. We have to go through P to get there. So we are literally here talking about 3/4 of the circumference. Okay. All right, so we can find our circumference and take 3/4 of it. But we definitely need the circumference. Circumference is 2 pi times the radius. You have a radius here of 10, so 2 pi times 10, or 20 pi. That is the circumference, okay? We want 3/4 of the circumference, okay? So we want 3/4 of 20 pi. We just need to simplify this, okay? Well, 4 goes into 25 times. So 3 times 5 is 15. We just end up with 15 pi. And really it's 15 pi meters. I'm not sure if there are units of measure on the test or not, but just to be thorough there. All right, 2 more. 24 just wants the area of the circle. Area of the circle is pi times the radius squared. Our radius here you can see is 2.2. So we have pi times 2.2 squared. And again, it wants it in terms of pi, so you don't even need to calculate pi. All you need to do is square 2.2 and put a pi after it. 2 times 2.2 is 4.84, and we have a pi after it. Again, that would actually be 4.84 pi meters. I'm not sure if that meters is there or not. All right. Last one here. What's the area of a sector? Remember the area of a sector? It's like a slice of pie, like a slice of pizza right there. Okay. That says the central angle is 170, so that was not at all drawn to scale. Okay. Make sure everything else is still there. Good. Okay. Central angle is 170, so we're actually looking at something that's almost half of the circle, but not quite. Okay. So this is 170 degrees central angle. Okay. This is the diameter is 9.1. Well, we want the radius because we're talking about area here, pi times radius squared. So if the diameter is 9.1, then the radius is half of that, or 9.1 divided by 2. Let's get that out of the way first. All right, 9.1 divided by 2 gives us 4.55. Do not round this at this point. Okay, we want to keep it as exact as possible until the very end. Okay, so 4.55 here. Now, we want a portion. This is part of the area of the whole circle. Part of the area of circle. Circle. Okay? Well, the area of the circle is pi times radius squared. And the part that we're working with is 170 degrees out of the 360. Okay, so we want 170 out of 360 times pi times 4.55 squared. I do believe you can type all of this in at the same time. Okay, so 4.55 squared pi will be on top. 4.55 times 4.55 times pi, which is approximately 3.141592 times and 170. Okay, so that's what we have on top. We'll hit equals there. And then divide that by the 360, and we should have our final answer there. It says round to the nearest tenth. So I have 30.7 approximately. All right, that is the last one. Please make sure that you understand all of these and that you have a complete version of the review.